Assalamu alaikum and good evening everyone. This is our final project for high performance and parallel computing. Our topic is parallel image processing using Google Cloud. We are three members in this group, me, SHAMEMA, AFRUZA, JOUTY, TAHMEDUR, RAHMAN and Naveenan Chandran. Google Cloud distributed computing and resources empower efficient picture filtering, augmentation, and feature extraction. This application leverages parallel computing and scalability to process multiple photos simultaneously, reducing processing time. It revolutionized computer vision, medical imaging, digital photography, and video processing by overcoming the time and computational constraint of conventional techniques. These are the three objectives. The first one is Google Cloud simultaneous image processing reduce processing time. The second one is Google Cloud scalability offers flexible task management and effective image data processing. Third one is Google Cloud simultaneous image processing allows real-time or near real-time photo analysis. The literature review demonstrates the benefits of Google Cloud distributed image processing in computer vision, medical imaging, digital photography, and video processing domains. Parallel computing and scalability addresses challenges related to large datasets and real-time processing. Efficient resource allocation and pre-trained model further optimize image processing workflows. Practical implementation and case studies validate the effectiveness of Google Cloud distributed image processing, enable faster processing times, and real-time or near real-time analysis. That's all for my part. The next part of this project will be explained by our another group members.
About our research methodology and approach, we have some implementing and evaluating parallel image processing algorithms on Google Cloud, and we also develop our code, configure cloud resources, and also conducting experiments. And after that, our sample images of datasets. About our datasets, it has variety, size, complexity, and real-world representations. And about existing image datasets are capturing and pre-processing images specifically for the research. After that, we collected relevant data from the articles, journals, and other to parallel image processing. About configure of Google Cloud resources, we have setting up some engine instances for parallel image processing and also determine number of instances and their specification based on experimental requirements. And after that, our detailed image processing algorithm. Uh, at first, we go for pre-processing, feature extraction, and then image manipulation or other operations. After that, we dividing our algorithm into smaller tasks for parallel execution on multiple instances in the cloud. And then about our system effectiveness, processing time, scalability, performance with increasing workload resources, and also resources utilizations. And then evaluating efficiency, speed, and effectiveness of parallel image processing on Google Cloud. About our results and discussion, our first part is anticipated results. For our anticipated results, it's improve our processing speed and reduction execution time due to parallelization. By using Google Cloud distributing computing capabilities, parallel image processing allows for concurrent execution of several tasks, operations on various aspects of single picture or set of images. And then our higher scalability, enabling the handling of larger image datasets by distributing the workload among a number of computational resources such as virtual machines or containers. Parallel image processing enables scalability dependent on the size and complexity of the picture collections. And after that, we analyze a massive picture collection or real-time image streams is made easier by systems capability to scale, which guarantee that can meet growing processing needs as an dataset expands. About our analysis and interpretation, we calculate the speed up attained by the parallelization to assess of efficiency of parallel approaches, and after that consider our elements like the size of picture collection, the complexity of the processing jobs, and the quantity of computer resources. And then about our image impact on image quality measures, examine how parallelization affects different picture quality matrices such as noise reduction, image augmentation, or feature extraction. And then our compare outcomes of sequential processing to those produced by parallel processing. What about our limitation and challenges? About our limitation of the parallelism strategies as selected, some images processing jobs or techniques may not be amenable to parallelization, leading to subpar speed up or restriction scalability. Talk about any difficulties encountered which, while converting algorithms or jobs to a parallel computing environment and how they affected the project as a whole. After our challenge with data pretreatment and transfer. While preparing data before parallel execution such as data cleaning, formatting, or resizing, discuss the effects of these difficulties on resource usage, processing time as a whole, address any concerns with data transfer efficiency that may arise, taking into account things like data size, network latency, and also synchronization problems. About our conclusion. About our conclusion, we improve processing speed in our for this project. For our processing speed on Google Cloud leverages distributed computing capabilities, leading to faster processing and reduced execution time. And about our scalability for larger datasets, Google Cloud scalability enables handling larger image dataset, accommodating growing computational demands, and ensuring efficient resources utilizations. And after that, our resource utilization effectively utilizing virtual machines or containers optimizes resource utilization, enhance overall efficiency in image processing tasks. Parallelization strategies. Task about parallelism or data parallelism enables workload distribution across multiple computer nodes, resulting in faster result, increase the productivity. That's it. Thank you. The coding part will be described by another group member. Assalamu alaikum.
So regards everyone, today I would like to present my code for parallel image processing using Google Cloud. This code allows for efficient processing of images by utilizing multiple threads for parallel execution. So let's dive into the code and see how it works. So first we import the necessary libraries, such as OS, Google Cloud, Concurrent Futures, TQDM, CV2 and NumPy. These libraries provide the functionality required for image processing, handling Google Cloud services, and creating a multiple threaded environment. Next, we set up the Google Cloud credential by specifying the path to our service account key file. This allows us to authenticate the access the required Google Cloud services. Moving on, we initialize the Google Cloud Storage client, which will be used to interact with the input and output buckets for image processing. Here comes the core of our code, the image processing function. This function takes an image as input and performs various processing steps on it. Let's go through each step in detail. So the first step is reading the image. We use the OpenCV library IAMRead function to read the image specified by the image name. Second step, applying a filter. In this example, we apply a Gaussian blur filter to smooth the image. The Gaussian blur function from OpenCV is used for this purpose. Step 3 is converting the image to grayscale. We use the CBT color function from OpenCV to convert the blurred image to grayscale. Followed by step 4 is performing the feature extraction. Here we use the canny edge detection algorithm from OpenCV to detect edges in the grayscale image. Then followed by the step 5. Saving the process image, we create a bucket object for the process images and specify the block name to save the process image in the bucket. The IMWrite function from OpenCV is used to save the image. Now that we have our image processing function defined, we can move on to the main part of the code. We start by retrieving a list of images from the input bucket. This list will serve as our input for parallel processing. Next, we create a thread pool executor to handle parallel execution. The thread pool executor class from the concurrent future module is used for this purpose. We iterate over each image in this list and submit a task to executor to process the image using the process image function. We also add a callback function to track the progress using the TKDM library, which provide a progress bar for our image processing. After submitting all the tasks, we shut down the executor and wait for all tasks to complete. We then calculate the number of successful and failed image processing tasks and display the results. And that's it. Our code for parallel image processing using Google Cloud is complete. It allows us to process images efficiently and in parallel, leveraging the power of multiple threads. Thank you for your attention, and I hope you found this presentation information. That's all.